Number 10. Describe whether each function could be used to model the graph. So they're kind of yes or no, but you gotta explain. So A is given in vertex form. So my vertex, I know, is gonna be right here. Horizontal shift. So plus 6, that means 6 to the left. Vertical shift, add 2. My vertex should be right there, so I'm gonna go no. And your reasoning could be because my vertex should be in quadrant 2, not in quadrant 1. B. This looks like factored form. So when it's in factored form, I can find my roots. My roots are these guys right here. My roots are going to be a -5 and 0 and a -8 and 0. So -5, 0, -8, 0. There should be my roots. So this one is also no, because my roots should be on the left side, not on the right side. So neither one of those functions could describe that graph. 11. Use your knowledge of reference points to write a function for a unique parabola that satisfies the given info. You've got one, should put x-intercept. There's only one x-intercept right here, -3 and 0, and they've already got it plotted. And there's a y-intercept at 0, 6. So could a parabola go through those two dots? Your answer is yes. If there's only one x-intercept, that means it is your vertex. So it's going to come down and touch the x-axis only once. Parabolas could come down and touch the x-axis twice, or they could never touch it at all. So each parabola can have one crossing, two crossings, or 0 crossing. If it only has one crossing on the x-axis, that is your vertex. So here we go. My vertex happens to be at left 3, 0. So I know my model is y equals a times x minus h squared plus k. So I'm going to plug some stuff into my model. Y equals a, and here's my horizontal shift. I shifted it 3 times to the left, so I know it's going to be x plus 3 squared, and my vertical shift is 0. Did not go up or down. Okay, now I got to find a, and I'm going to use this point 0, 6. If you want to find the value of a, you got to plug in a point for x and y. So I'm going to replace my x with 0, my y with 6. 6 equals a times 0 plus 3 squared. 6 equals a times 9. Divide 9, divide 9. My a is equal to, divide those both by 3, 2/3. So my final answer is y equals 2/3 x plus 3 squared. That model will describe exactly that graph. 12. Okay, you're given two functions. They're quadratics. Because of the x squares, you know they're going to be parabolas. Graph them, but change them to vertex form. Okay, vertex form. The model for vertex form we just did, y equals a times x minus h squared plus k. Alright, so you're going to create a perfect square. So this first one, my question is, I'm wondering about this 12. Is the 12 the number of my choice, or would I prefer it to be something else? And I would prefer it to be not 12, so they gave me a bogus number. I want it to be a 16. The very moment I add 16 to this problem, I must turn right around and take it away. Take it right back. Because if I add something and take it away, it's like I never was there. I never touched it. Okay, now, if the number is 16, and when you factor it, you can factor this as x minus 4 times x minus 4, because a minus 4 and a minus 4 will add to give you a -8, and a minus 4 times a minus 4 will give you a 16. So that's how I found 16. I knew the middle comes from adding. So I asked myself, what number at its exact self is a negative 8? And that number is a minus 4. And then I knew this last number comes from timesing, so I did a minus 4 times itself and got 16. So 16 was what I wanted. When it's 16, it factors like this, which is x minus 4 squared. And then I just got to worry about my 12 they gave me, and the negative 16 I took away, and that is a negative 4. So now I'm going to call it good. Without much work, I just changed it into vertex form. Now vertex form, put your pen on 0, 0. Horizontal shift, go right 4. Vertical shift, go down 4. Right 4, down 4. There we go. Now, if you know one dot, I'm going to try a dot close to it. I'm going to try 5. So going right 5, and if I plug 5 into my model, 5 take away 4 is 1, 1 squared is 1, 1 minus 4 is a minus 3. So I'm going to go over 5 down 3, and then reflect it across my vertex. When my vertex falls on the axis of symmetry, done. My parabola looks just like that. Okay, to save time, we're going to skip this. The only thing you need to know, you can work this out on your own. We got to hustle through this. X squared plus 6x. Scoot to 10 over. And what would you want here? Do you want a 10, or is there a number that would be better? And the answer is there is a number that would be better, and it is not 10. It's close to 10. What number at itself gives you the 6? So it's 3x plus 3x, and then times that. What you wanted really was a 9. Because if you got a 9, it'll factor to x plus 3 squared. So add a 9 minus 9, etc., etc. Number 13. Oh, domain and range. We didn't do domain and range. Okay, the domain. Let's look back on this first one. Your domain. The domain is the left and right. So this parabola is going to continue forever. As it goes up, it kind of goes left. As it goes right, or as it goes up on the right side, it's going to go right. So it is going to cover everything on the x-axis. So my domain is my x's, all of these. And each number is going to be represented all the way from negative infinity to positive infinity. My range, however, the range is what's covered on the y-axis, up and down. And this vertex is a minimum. There is nothing that goes lower than that point right there. So that's my minimum. My maximum, this goes all the way up on the y to infinity. So my range, the lowest is a negative 4, and I put a bracket because I include that negative 4 all the way to the highest, which is infinity. There is your domain and range. Domain is what's covered on the x-axis. Range is what's covered on the y-axis. Okay, factored form. So factored form is the roots. So I'm going to factor out a 3x. You're going to get 3x multiplied by x minus 5. So, my question is, what can I plug in for those x's that's going to make my y's be zeros? And I can plug in right here. I can plug in a 5. That's going to give me a 0. But what can I plug in right here that's going to give me a 0? 0. Because 3 times 0 is going to be a 0. 0 minus 5 is a negative 5. So those are my two roots. When I graph them, 0, 0 over 5, 0. Okay, what is your next move? You got to find the vertex. The vertex is going to be halfway between those two. So the midpoint. So the midpoint of 5 and 0, add them up, cut that in half. Your midpoint should be 2.5. So right here at 2.5. And if you know you have to go over 2.5, the next question is, do you go up or do you go down? So you have got to take this 2.5 and plug it into your model where the x's are. Do the math and it will give you the y. So I'm going to take a 2.5 either into my original model or the one you factored. It doesn't matter. So if I do 3 times 2.5 squared minus 15 times 2.5. Punch in your calculator. Add them together. 15 times 2.5. You should get a negative 18.75. So that's clear down here. Parabola looks like that. You're good. So the domain and range. Domain is what's covered on the x-axis. Everything. Negative infinity to positive infinity. Your range, this is also a minimum. So your range is going to be, the lowest is a negative 18.75, and the maximum is going to be infinity. Okay. Let's look at this one. First move, I'm going to divide everything by 6. So I'm going to rewrite this as y equals 6 times x squared. What's 72 divided by 6? 72 divided 6. That's 12x. 120 divided by 6 is that 20. Okay, now after I factored out a 6, I'm going to keep going. I'm going to do what times what's going to give me my x squared. That's going to be an x and an x. What multiplies and gives me 20, but at the same time adds and gives you a 12. And I'm going to go with a 10 and a 2. And are they positives or negatives? One of each. They both got to be positive. They got to add and give you 12 times and give you positive 20. There we go. Now my roots, when it's factored like this, the roots are easy to find. Your roots are going to be what you plug in to make your answer be 0. So my roots are going to be a negative 10. Because when I plug negative 10 in there, that's a 0. That's a negative 8. 0 times negative 8 times 6 is 0. And then this one is a negative 2. So my roots are clear over here. Negative 10 and 0, negative 2 and 0. My axis of symmetry's got to be dead center of those, your midpoint. So you find the average, negative 10, negative 2, add them up. Negative 12, cut that in half. Negative 6. Now your vertex, if you know you're going to go over 6, take negative 6 and plug it in. You can plug it into the original, or to this one, or to this one. Doesn't matter because they're all three the exact same. So I'm going to plug it in to this one. So 6 times negative 6 plus 10 is 4. Negative 6 plus 2, what's that, a negative 4? So 6 times 4 times a negative 4. Ooh, what is that? 24 times a negative 4. So that's a negative 96. So my vertex is going to be clear down here, negative 96. My domain is going to be all real numbers, or anything on the number line from negative infinity to positive infinity. That's the same as all real numbers. My range is going to be, my lowest point is negative 96. It never is going to go lower than negative 96 on the y, but if it continues, it's going to go forever up and down to infinity. Alright, how many more questions do we have? We got too many questions. Alright, graph it in standard form. No, we have not done that. We morphed it to vertex, we morphed it to factored. So this one, you're given one problem and you need to graph it each of the 3 ways. To save time, we've already done vertex, we've already done factored, we have not done standard, so let's do standard. When it's in standard, you can find A, B, and C without too much sweat. A is the number of squares you've got, B is the number of linears you've got, and C is the number of ones you've got. So C is 12. Okay, your constant, that's your y-intercept. So up here on the y-axis at 12, you got a dot. Now, the most important dot is your vertex. And I know my line of symmetry, or my axis of symmetry, is this, negative b divided by 2a. So it's going to be a negative 7 divided by 2 times 1. And that is going to be some rational number. It's not a whole number. So it's 7 divided by 2. It is 3.5. Alright, so on my table, my rational number, 3.5. I'm going to go over 3.5, so that's at least an easy rational number. This is my axis of symmetry. This point reflects across somewhere over here. And now, this is not a dot. I should erase that. That's just how far I'm going over. Because the question is, I got to find that vertex. The only way to find the vertex, take 3.5, plug it into your model, square it, plug it in here, so it's going to be 3.5 squared minus 7 times 3.5 plus 12. So that's all calculator. 3.5 squared. And you should get a negative 0.25. So negative 0.25 is right there. Parabola is done. Now when you graph it in vertex and factored, it's going to be the same line over itself. Your vertex is going to be the exact same spot, but you might get more points. So in standard we got y-intercepts. In factored we will get the roots. You're going to get these x-intercepts. And in vertex you're going to get points that are close to the vertex. These points are not very close to the vertex. They're kind of far away. So each of the three ways gives you the exact same picture when you're all done. Last one, write a quadratic given the vertex. Okay, that's a hint. You want to use the vertex model, which is y equals a x minus h squared plus k. And I always just draw a little picture. Over 7, down 4. There's my vertex. So I shifted it right and then down. So it's going to be a x minus 7 squared minus 4. The trick is right here, your horizontal shift. Because I shifted it right 7, I know it should be a minus 7. Okay, now, this point right here is a point over 5 up 8. What do you do with the point? Your common theme throughout this whole chapter, plug it in, plug it in, plug it in, plug it in. Take this 5, plug it in for x. Take this 8, plug it in for y. 8 equals a times 5 minus 7 squared minus 4. Do the math. That's a minus 2. Minus 2 squared is minus 2 times minus 2. So you got this. A equals 4 times a minus 4. Undo all these 4s. Plus 4, plus 4. 12 equals 4a. Divide by 4, divide by 4. A should be 3. So your final answer is y equals 3 times the quantity x minus 7 squared minus 4. Last one. The roots. Okay, the roots are the hint that it's got to be y equals a times x plus or minus some root times x plus or minus some root. Okay, your roots, I just draw a little picture. Negative 4 is 0, that's somewhere here, and 2, 0. Okay, there are your roots. So this is tricky, because when you plug it in, it's kind of backwards. X, the roots are 4 and 2. The question is it a plus 4 or minus 4? Plus 2 or minus 2? And it is going to be a plus 4. And it's going to be a minus 2. Because when I plug those points in, x, y, when I plug in a negative 4 and 0 and 2 and 0, when I plug in a negative 4 to my model, it better give me a 0 for an answer. When I plug 2 into my model, it better give me 0 for an answer, and it does. And that is it.